Welcome to the Aricent Smart Community demo. In this demo, we are going to demonstrate Aricent IoT M2M software frameworks and solutions. This demo is set up in the Executive Briefing Center, Gurgaon Tikri office. The devices and equipments in this demo contains the smart street lights, smart bulbs and digital photo frames, Zigbee-based temperature and humidity sensors, BLE-based light sensors, parking toy cars, and ZIV PLC Prime smart meters. The other hidden devices are the Intel Edison board on which the Aricent IoT gateway is running, the network Zigbee smart plugs, parking IR sensors, Freescale Zigbee coordinator, and TI C1000 DSP Prime PLC board. Now, from the Smart Community homepage, we will select the Estate Management option. The dashboard provides quick view of the status of the various smart devices and sensors at the community level, such as ambient temperature, ambient humidity, visitor car parking status, and emergency conditions such as fire or smoke in the community. The energy management. With this option, Estate Manager will be able to monitor and control various devices and equipments such as street lights, HVACs, air conditioner, heaters, pool pumps, and washing machines. The Estate Manager will be able to control the street light manually using the street light button. Also, normally, street light will be controlled by light sensor. During the daytime, the street light will be off, and in the evening and night, the light sensor will activate the street lights. The light sensor that we have used in the demo is from the TI, which is a multi-sensor module which has been configured to act as a light sensor. The climate control. With this option, the Estate Manager will be able to monitor and control the various ambient and environmental sensors such as temperature, humidity, air quality data such as carbon monoxide, lead, and ozone. To simulate the fire condition, we will reduce the temperature threshold. It will activate the fire alarm. Now we will change the threshold back to the normal level. This will deactivate the fire alarm. The next option is parking monitoring. This option allows the Estate Manager to check the status of the various parking lots in the visitor area of the community. As we see, when the toy car is removed, there is one vacant spot, and when the car is parked again, there is no available parking slots. We have another demo with real car parking and real cars. Emergency control. With this option, Estate Manager can raise various alarms in the community. The fire and the smoke alarm can alert the community members of smoke or fire in the community. The other set of the alarms are the flood alarm, elevator fault alarm, and security breach alarms. The next option is home automation for residential users. Each user is given secured access to the application to control and monitor individual user smart devices. Various choices are provided to the user based on his or her preference, whether it is savings mode, savings or comfort mode, or comfort users. Based on this choice, certain parameters are automatically set for home automation purpose. Based on the selected preference, user has various options such as Smart Home for instant device control and settings, Savings Zones for extra savings and consumption details, Comfort Zone for setting automation profiles, and other admin options for utility controls. Now, using the smart home options, the user has options to have the appliance settings, and the instant control. Here we can control the bulb settings like the maximum power rating and the normal settings. What is appliance address? From the appliance control, the devices can be controlled instantly. As we see here, the bulb is currently on, and with this option we can control its status and put it off. Now we can put it on again, and this is based on the Zigbee control. The saving zone provides the options to enhance the saving of the current devices. So based on the high tariff, medium tariff and normal tariff, what devices should be controlled can be set in this option. With the consumption option, the user has the snapshot of his device consumption history, and system also provides predictive consumption based on its historical data and current settings. The prediction data uses the R tool for the analytics. The system provides the yearly, monthly and the daily data for both the cost and the consumption. Also, the user has the option to look into the device level consumption, so user can check which of his device is consuming how much of the consumption and what is the cost. With this, user has better control over his consumption and can save on his electricity bills. With the do not disturb option, the user can set when not to set the devices automatically based on the settings. Now, with the comfort zone option, the user has an option to set the various automation profiles for the weekday, weekend and vacation. On the weekday, he can decide which all devices should be on and off based on the time of the day, and similarly for the weekend and the vacation, it can set which all devices should be controlled. Using the admin options, the user can know when the utility has sent the tariff and the load shed triggers. These are observed in the utility events. As you can see, there are a lot of load shed and pricing signals. This load shed is of 30% from 10 a.m. to 12 p.m. Similarly, there is a pricing event for the entire time of the day, and the utility sends the tariff cents per unit. Now in this demo, we can see how the devices are getting controlled based on the various automation profiles and the pricings and the load shed triggers that are sent by the utility. As you can see, the green ones are for the normal tariffs, the orange is for the medium, and the red is for the high tariff. There is also a load shed trigger from 10 a.m. to 12 p.m. So you can see the various devices being controlled on and off, and the HVAC temperature is being controlled based on these settings. Thank you. Welcome to the smart parking demo. We will start with the setup details. The setup is running in the Aricent corporate office in the Gurgaon. It consists of 3 labellium parking sensors inserted into the hole and covered with epoxy resin. The gateway is based on the Intel Edison and has a labellium XB receiver module that receives the sensor signals over 802.15.4 radio mesh network. The parking sensors from the labellium consist of magnetic and thermal sensors inside a sealed casing. It has the same 802.15.4 Zigbee module. The box is filled with the silicon gel. Now we will access the Smart Community web application, from where we can access and monitor the status of various parking lots and its parking slots. This web application also supports smart metering and smart lighting. As we can see, there is one parking lot in the Gurgaon with 0 available parking slot. There are 3 parking sensors, and right now there are 2 cars parked while one of the sensor is not operational. Now we will move one of the cars parked in the slot number 1 and check the status of the parking. The parking status polling by the sensors are done at 30-second interval, and 2 such samples are taken to report the parking status. The sampling interval of 30 seconds is optimized for a battery life of around 5 years. Now we see that the status has changed from occupied to vacant, and similarly the available count has increased to 1 from 0. We will move back the car to the parking slot and check the status of the parking. We can see that the available count has again become 0. We will try with the other slot and move the car parked in the slot number 2. The system supports various logging and reporting features, and the administrator can check the status reported by each and every sensor, and the information that is passed is the time, the lot and the slot details. This helps the administrator to debug the status reported by each sensor. Now we can see that the available count has again increased to 1. Also from the logs we can see the status reported by the sensor 2. Reporting feature, the web application allows the administrator to get the statistics and report on hourly and monthly basis. Also, the report specifies the maximum and the minimum occupancy status on a daily basis for each of the parking lots. These statistics and reports can be gathered from each parking lot, and analytics application in the cloud can generate meaningful and value-added information for the parking service provider. The diagnostic application allows the operator to monitor the status of each of the sensors which are deployed in the network and check whether they are running perfectly or not. The provisioning interface allows the administrator to provision each of the sensors in the web application. Thank you. Welcome to the Aricent smart metering demo, which is part of the smart infrastructure solution. Currently, the Aricent smart metering supports 2 types of the meter. One is the ZIV Prime PLC meter and another is Discover-G IP meter. The Discover-G IP meter is based on the REST protocols, and it provides REST APIs to access the instant energy in the kilowatt and the energy consumption in the kilowatt hour on an hourly, daily and monthly basis. This is the smart metering web application. As you can see, there are 2 meters in Bangalore and Gurgaon. We will see the Gurgaon meters. The reports option gives the snapshot of the kilowatt instant consumption of the meter and the kilowatt hour energy consumption on a daily basis. This information is based on the REST API invoked by the Aricent Gateway module and reported to the meter web application. The next demo is based on the ZIV Prime PLC based DLMS meters. As you see in the network, there is a PLC data concentrator which runs on the Aricent IoT gateway. The PLC data concentrator is connected to the PLC network, and to the networks we have the different smart meters. The PLC data concentrator has a DLMS COSM stack and a DLMS application. DLMS is a metering protocol using which the metering information can be obtained from the smart meters. Now this is the smart metering web application. As you can see, there are currently 2 meters, one in the smart community and one in the home. We will access the smart community meter and see what are the different options it supports. As we can see, there are currently 3 options. One is the current reading, which is also called the demand meter read. Another is the metering information, which provides the nameplate information. And third is the disconnect power supply, which means that you can remotely connect and disconnect the meter. And this is useful when the user is not paying the bills or for the maintenance purpose. Now we will run the first use case of remote meter disconnect. As we can see, the meter shows the meter got disconnected as shown in the red light, while the PLM is up so that we can communicate with the meter. Now we will connect the meter again and see that the red light is off and the meter supplies the power to the light load connected to the meter. Now we will see from the current reading or the demand reading what is the current consumption in terms of the wattage and the kilowatt hour. As we can see, the current reading, it shows 10 watt and the total consumption is around 4500 watt hour. Thank you. For any further details, contact the given web link on the Aricent website.